Oh, hello. Here we go. I didn't quite get started on time. There we go. So we are still on lesson 11. We're getting ready to we did day 1 yesterday, and we're getting ready to start day 2 today, which is going to be on page 67. You are going to be doing these 4 problems, there's 6 problems there. And if you are struggling just a little bit, I am going to strongly encourage you to go back and re-watch that video, the lesson 11 video. It will be very useful to you as you are working through now that we're doing two-digit takeaway, two-digit. Manipulating your value discs will be very important. Those of you who are distance learners have made a set of those, and you will definitely need those. You should have used them yesterday, and I'm strongly encouraging you to use those today. So you're going to do D both problems, E both problems, F both problems, and I'm going to remind you that you need to, without question, you need to use, oops, that's not a U. You need to use the value discs. They are so important. I know maybe yesterday things seemed very easy, but now that we're going to be doing the two-digit portion there, you need to use those value discs. Okay, so then you're going to be coming over to the second page of the problem set and doing the number 3. And then also there are 2 word problems that you need to do, 4 and 5. Be especially careful that you read carefully number 5, because if you're not careful, you're going to make the same mistake that I made, and it took me a few minutes to figure out why I didn't have the answer correct, but I did eventually see it. So I'm going to remind you on number 5 that you need to read that one carefully, and again, I'm going to say that you need to use the value discs as you figure these out. Those value discs for a while. The next 3 or 4 lessons will be very important to you. Then once you get finished with that, you're going to go back and double check your work. I am going to show you the answers here in just a few minutes. And of course, you need to make sure that you send the actual exit ticket to your teacher. We're going to want to see the equation that you use to solve this problem, solve for the missing part, and then you definitely need to use those values, those place value discs. I'm going to tell you that without those, these problems might be difficult. And I'm going to tell the parents out there, and I should have said this yesterday and I didn't, please do not do the standard algorithm with your students just yet. That is coming in a few days. Right now, manipulating the value discs is what we're trying to go for. So we need to know what the missing part is. We want to see the equation that you're going to do, and then you should be using your value discs to solve those problems. Okay, so with that, I am going to tell you to either shut the video off and then come back to it later when I will go over the answers to the problems today. And then, of course, you need to send your exit ticket to your teacher. All right, so you're going to pause the video. Hey, are you back? Okay, so I am going to tell you that just like I did yesterday, I did put these on another piece of paper so that it was easier for me to be able to manipulate what I was doing for our students here, and probably for you as well. These problems were a little bit more complicated, and of course I started on 2D here and 2D to the D problem here. So I want to go over these with you rather than on the paper, at least for these first couple. And hang on for just a second. Okay, I think that I am going to take the time on a couple of these to show you how to use these value discs. I'm pretty sure you've already figured it out, but I want to demonstrate. So when you do the value discs with decomposing a 10, you're always going to start with your whole number. So my whole number, take away my part, will give me the other part. So whole number is the only number that is going to be represented with my value discs. So I need to show 47, so 4 tens, and you only really need to have your 1s and 10s for this. and then 7 ones. I'm just going to demonstrate this because I don't know, for me it really helped me to be able to see what I was doing. That's 5, 6, 7. So then I had to ask myself the question as I'm looking at, let's see, 47 take away 22 equals, the first question I'm asking myself is, can I take 2 ones away from 7 ones? So here's my 7 ones represented by my whole, and I can see that yes, I can take 2 ones away. So I take away 2 ones. I don't have just ones to take away. I also have to take away tens. I took away the 2 ones, but I also have to take away now 2 tens. So I'm taking away 2 tens and seeing what that leaves me. So if I take away the ones and then take away the tens, I can see that I am left with 2 tens and 5 ones, which gives me 25. Therefore, 47 take away 22 is 25, which is my whole, my part that I knew, and the part that I was figuring out. So there's a good demonstration, and I'm going to demonstrate the next one as well. So if you were struggling just a little bit, hopefully this will help you just a bit to be able to do it. So let's go ahead and do, this time this problem is not too much different, except it's 41 take away 22 equals, and I'm going to set my problem up again by showing the whole number first, 10, 20, 30, 40, and 1. Remember, when we're doing a subtraction problem, we only show the whole and not any of the parts. We're going to be manipulating the parts but not showing the parts. Then I ask myself the question, can I take 2 ones away from 1, 1? Well, here's that 1, 1. Can I take 2 away from that? Well, I can't, so I know I have to decompose a 10. So I'm decomposing, taking that 10 out, and I'm going to replace it now with 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Of course, I don't have these all turned over the right way because they didn't come out of my pile that way. So now, instead of having 1, 1, I now have, you can see easily, 11 ones. So 3 tens are left and 11 ones. I re-ask the question, can I take 2 ones away from 11 ones? Well, I certainly can. I'm going to take this one and I'm going to take this one. That leaves me with 9 ones. But I have to remember that I also still have to take 2 tens away from what I started with, which was 4 tens, but I regroup, so now I have 3. I'm going to take 2 tens away from that, which leaves me with 1 10. Therefore, 41 take away 22 is 19. If you haven't been using your manipulatives with these problems, man, you need to go back and redo that. Your number bond shows the whole, which was 41, the part that they gave you, which was 22, and we were coming up with the missing part, which was 19. Okay, I'm going to just do a couple more of those. I know you're thinking, Miss Star, we get it, but just in case you didn't get it. See that big thing, use your value discs on all of these problems? Yeah, because it will make it easier for you to understand, especially as we continue to move into more complicated equations. So 44 take away 16 equals, I'm going to set that up. Remember, I'm starting with my whole, and I'm only going to represent the whole. So here's my 40, and one more to make 40. Whoops, sorry, that needs to be 3 more because it's 44. Alrighty, so there I am. There's my whole that's represented with 4 tens and 4 ones. The first question I want to ask is, can I take 6 ones away from 4 ones? Well, here's my 4 ones. Can I take 6 away from those 4 ones? Nope, I can't. So I know I'm going to have to decompose a 10 or break it apart back into ones. So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now I can see that I have, can you see that I have, whoops, sorry, you can't because I didn't push them up high enough for you. I now have 14 ones. Can I take those 6 ones away now from the 14 ones? Well, I certainly can. 1, 2, 3, 4, 5, and 6. I'm going to take those away, and I can see that that leaves me with 8. So there's my 8. But I also have to remember that I have to take away 110 from my tens. So I'm going to take 110, which leaves me with 2 tens and 28. Therefore, 44 take away 16 is 28. If you're not using those value discs, I need you to do that because I'm not going to see you doing it. I will be able to see my face-to-face kids doing it, but not you. So I'm hoping that you're not skipping that step. That would not be a good plan. Let's do the very last one here. We're going to do 44, take away 26, equals, okay, you can already see that I have that worked out, but I want you to watch the process just in case you're having trouble. So I'm going to only represent the whole, which is my first number. I'm representing the whole, which in this case is 44 again. 1, 2, 3, 4, and I need 4 ones. 1, 2, 3, 4. And the first question, again, I am going to ask myself is, can I take 6 ones away from 4 ones? Here's my 6 ones, here's my 4 ones. I only have the 4 ones represented, but I can see that there's not enough. There's only 4, which tells me I'm going to have to decompose or change a 10 for 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My value has not changed. It still represents 44, but instead of having 4 tens, I only have 3 tens, and now I have 14 ones. Can I take that 6 ones away from my 14 ones? I sure can. 1, 2, 3, 4, 5, 6. That leaves me with 8 ones. I love putting them together like that because I can see just by looking at it that I have 8 ones because I keep that row of 5 all the time. But I still have to remember that I'm not just subtracting 6 ones, I'm also subtracting 2 tens. There goes my 2 tens, which leaves me with 1 10, and therefore 44 take away 26 is 18. Parents, please notice that I am not using the standard algorithm. If you're tempted to teach your student the standard algorithm, please refrain for right now. That is coming, but let it come in the natural order of things with this new math program. Hopefully you're feeling a little more comfortable. This is closer to what you're used to seeing, and it's also going to be very useful to your student to be able to do those problems. Okay, so I think I'm not going to demonstrate these next ones. I will just show you what the answers are. 70 take away 28 is 42. 70 was my whole, 28 was the known part, and 42 was the part I had to figure out. I hope you used your value disc on all of these problems. Okay, F, the second problem, was 80 take away 28, which gave us 52. I don't want to see a standard algorithm. I want to see those problems being worked with the value discs. The whole was 80. We were given 28, and we had to come up with 52. And then on problem number 3, that was this one right here. You may have shown it here. I'm just going to show it here. 56 take away 28. Did you use your value discs? I hope that you did. 56 take away 28. 56 was my whole. 28 was the value that I was given as a part, and I had to find the other part. If you're tempted to use the standard algorithm with your student, please don't. And then you need to go to your problem set to see problems 4 and 5, and I am going there right now. Oops, it's over here. I'm going to take a look at problem 4 and 5. Here we go. Oh, there they are right there. So let's take a look at problem 4 and we're going to just start with problem 4, if that would be okay. So I'm making sure that I'm reading the problem and that I am using cubes and read, draw, and write. So I'm circling the numbers, which I did. There are 63 problems on the math test. Tamara answered 48 of them correctly, and the rest were incorrect. How many problems did she answer incorrectly? So I know that my whole was 68, so here's my whole. 68. Whoops, not 68. Boy, Mr. Look at your numbers. 63. And the part that I do know was 48. Those are the ones that she got correct. So I have that part. That part was 48. And I'm trying to find out how many she answered incorrectly. So I've been given a whole and one of the parts. I have to come up with the other part. So to do that, I am going to go back to my my chart. I have 63, take away 48, 63 take away 48 equals, and it looks like I've got 15 there. Let's see if that works out right. All right, so I'm going to start by representing 63, 1, 6, or 10, 20, 30, 40, 50, and 60. Remember, we're always representing the whole when we're doing a subtraction problem. 60 and 1, 2, and 3. We're representing 3. And I have to ask myself the question, can I take those 8 ones away from 3 ones? Well, my 3 ones is represented here, and I don't have enough to take away 8 ones. So that means I'm going to have to decompose a 10, which is not changing the value, but changing it from a 10 to 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now the value is still the same. That 10 still exists. It just happens to be over in the ones now. So instead of having just 3 ones, I now have 13 ones. Can I take 8 ones away from 13 ones? I certainly can. 1, 2, 3, 4, 5, 6, 7, 8. But I also have to remember that I'm going to have to take away 4 tens. I can take 4 tens away from that 6 tens. 10, 20, 30, 40. That leaves me with 1 10. Hence, 1 10 and 5 ones is 15. Man, oh man, oh man. Do you see why I want you to use the value discs on all of these problems that we're doing yesterday and today? Now we're going to sneak on down to problem number 5. Hang on just a second. All right, so here we go. We're going to take a look at problem number 5. Mr. Ross has 7 fewer students than Mrs. Jordan. Mr. Ross has 35 students. How many students does Mrs. Jordan have? So let's start with what we know. We know that Mr. Ross, there's my R, had 35 students, so I put that into my tape model. And I know that he has 7 fewer students than Mrs. Jordan, so I've put that in my tape model along with my 35, and knowing that that's going to be 7 less than 35. So 35 and 7 less will help me to understand what Mrs. Jordan has. So the first time I did this problem, because I saw the word fewer, I didn't read it very carefully, and I did it as a subtraction problem. And when I checked myself, I could see that I did not have what I should have been looking for. I needed to find out how many students Mrs. Jordan had, and it was not reasonable that I came up with 28 when I subtracted that. Would it be reasonable that Mrs. Jordan only had 28 students? So I knew that I had made a mistake and that I needed to go back and read more carefully why I had that mistake. When I realized that this was an addition problem and I added 35 and 7, that gave me 42 when I just add 42 when I used, I didn't even have to use my value disc because it was just an easy problem. 7 plus 5, let's see how, yeah, anyway, so it gave me 42, and you could use your value disc to help you with that as well, which made it reasonable that Mrs. Jordan would have had 42 students. That could also be checked by thinking 42 take away that 7 would then give me what Mr. Ross had in his class, which would have been 35. My number bond would have been the whole was missing. That was missing when I started, but I did have the 2 parts. I had 35 and 7. When I put those 2 together, I came up with my whole, which was what I was trying to find, which was 42. All right, so hopefully you didn't make that same boo-boo that I made, and if you did, I hope you figured out why it was a boo-boo. And of course, now you're going to be sending your exit ticket to your teacher. Make sure that you use your value discs. They're so important, my friends. Please use them. And we also want to see your equation so we can see how you solve this problem. And you have yourself a great day of learning.